For us, design is more deep-rooted than just what your intent is. What we don't know in a lot of these cases what our intent is. I had a thought first to start off with saying that, where there was a time when we used to use CAD, we used to use BIM, but I'm going to go in reverse with this entire thing, that what we are doing today versus what we have done in the last 20 years. So it's a sort of a reverse chronology of the same thing. How one function is connected to the other function, and how this parent-child relationships work. So how one function is important connected to the other one, and that sort of gives us this interrelationship diagram.
I invite Manish Gulati, the founding partner of mofastudio.
So yes, those 3,000 images were generated in 12.5 minutes on Midjourney. And today I'm here to not talk about the projects. I'm from this firm called mofastudio. We've been around for 20 years now. And this is what I'm here to talk about. More than just doing the projects, it's more about this factor, the known and the unknown. In most of the design projects, it's always the known factor with the architect's mind. It's one person, team, collaboration. You have an idea. You already know what you're going to build. And from there on, you start, you know the results. You have a sketch, you have a line, and from there you start building that whole and start resolving it. Our whole journey in last few years has been working with a design where we don't know anything. And that's where words like inclusiveness, democratization of design process, and using the machines. It's like having people on your team, but for us, even the machines are as important, where we are feeding in the data, we're using the simulations. We start with, so the whole talk today has been divided into these various stories of how these various projects have happened, how we've used inclusiveness, how emergent design, and how we don't know what we are going to be finally working with. It's a very interesting project that we've just started working on, and where we're using AI to sort of work around. The theme was very simple. We wanted to just experiment a Wes Anderson style of combination of a city which is like Paris and Old Delhi put together. Some images of Old Delhi, images from Wes Anderson's movie, and we fed in the data into AI, and we got some very interesting results. And most of these results ended up talking about the color schemes, the perfect colors of Wes Anderson, and this surrealistic combination of Paris and Delhi. And these images started to appear with these various prompts. And these images became the inspiration for us to work out the interior space and to work out various kind of colors and textures and sort of a perfect combination of what AI could do with you. Going further, so that's just a space coming up. We're working on another project, which is a 3D printed clubhouse. It's a public building we're doing in Bangalore, one of the first 3D printed buildings of the country, where we used the three factors. We used the AI to visualize the spaces for us. At the same time, we have not drawn a single line or a plan. What we've done instead, these are some visuals that we are developing simultaneously while the design is getting developed. So there's no plan, there's no line, there's no sort of intent which has been drawn. And what we call the generative design, we've taken the area And we are feeding this area with a plugin which is called termite nesting. It's a simple relationship of a parent and a child relationship. How one function is connected to the other function, and how this parent-child relationships work. So how one function is important, connected to the other one, and that sort of gives us this interrelationship diagram. What we have done is fed that Excel, and using termite nesting, every time the data changes on an Excel sheet, the configuration of the building changes. And this is a sort of an iteration that we've been working with in coming it together. And the third part of this is, this project is going to be sort of 3D printed to come together in the form of layers. And for us, design is more deep-rooted than just what your intent is. We don't know in a lot of these cases what our intent is. And I'm a lover of technology. I'm somebody who's grown up with technology. This is the space which is coming up with. And this whole presentation is going in reverse. I had a thought first to start off with saying that, there was a time when we used to use CAD, we used to use BIM. But I'm going to go in reverse with this entire thing, that what we are doing today versus what we have done in the last 20 years. So it's a sort of a reverse chronology of the same thing. A residence that we started during COVID, a completely emergent design. The client had a very simple brief. They wanted to create a very large subterranean space, a basement which would receive a lot of natural sunlight, enough so that we could grow an entire garden or trees inside it. Now, rather than going with a standard way of drawing a plan, we fed that data into an algorithm, and we got more than 27,000 iterations within the 12 hours. And these 27,000 iterations were then refed into the computer with the functional layouts. And what we got was multiple floor plates, multiple floor plans, each one adhering to one condition, that the basement would achieve more than 60 to 70% of natural sunlight. And based on this, the plan sort of started emerging, and we got a section where you see a reverse section. The basement and the lower floors are almost 40 to 50 feet high, whereas the house sort of becomes more dense as you go up. That's a sunlight study to understand, and even today, when I stand there, we did the simulation of the predictions of particular date and particular time in a particular season. The sun shadows and the sunlight and the lux levels were exactly how we simulated them. Another project of the emergent design where we did a small installation, no plans were made. We wanted to create a landscape using shipping pallets. And here, rather than coming up with an idea of how this whole installation would be, we just had an Excel sheet of XY coordinates. And those XY coordinates were used to just stack these pallets to create these hillocks, which are more of the nostalgic memories of my childhood, going to the ruins in Delhi, to Lodi Gardens, where you got these sort of ruins with grass growing over it, and as kids, you go up, you have your Sunday picnics. So this was more to kind of understand and come up with something where you're not using the standard way of making a drawing or making a model or doing anything. It's one of the largest projects that we did, again using a similar kind of an approach, where we said there's an existing contour, and we did the terrain mapping for that contour so that the natural water flow doesn't stop. We divided the entire contour in a grid of cubes, and these cubes, wherever they appeared on whichever part of the land, and this to us takes us back to the villages in Himachal, where every house is sitting on its respective contour. So rather than leveling the land, flattening the land, we used it to our own advantage, and a plan sort of emerged from this whole technique of having these equal distribution of internal streets as well as these residential spaces which moved at various levels, creating these wonderful internal streets with existing trees. We used the existing trees to our advantage, and we moved all these units within that. I'm going to skip because there's lots to show. We also, now since this is reverse in chronology, something that we have been dabbling with for the last 15 years is CNC file-to-factory production of houses. And I use the term production of architecture is because over the years now, 90% of our projects are not constructed using RCC on site. because it reduces, we want to reduce the carbon footprint, we want to reduce the pollution, we want to reduce all of that. So most of the projects now are factory produced and they are brought to the site. So one of the largest projects that we've done in Goa, about 45,000 square feet of roof space, where the entire module, every part of the roof, individual modules were, this is a topological optimization. We use the roof in order to reduce steel. It's a government project done at L1 costs. So one of the most reasonably done projects in the country. We did the fabrication analysis. We worked out the entire roof, which is a doubly curved roof inspired from the waves of the sea, in the form of how it can be manufactured in the simplest possible manner. The drawings were automated within the office. More than 5,000 drawings were done within a span of 15 days, all automated. The accurate data retrieval, down to the core that these pipes could be individually welded within the factories to get a roof which is within the tolerance of plus minus 3 mm. A very highly accurately done roof at that scale at extremely low costs. So it shows you the complexity of the roof, the skylights, where everything was pre-analyzed, pre-simulated, right from the lux levels to the rainwater flows, to the water flows and how it would react to the wind and the water and the sunlight. The roofing material itself is one of the cheapest color-coated metal sheets, which was used using an origamic technique. We programmed the entire thing within the office as a simple cut-fold system, and all these individual roof panels mount themselves on the complex roof, thereby forming a seamless surface that represents what we were wanting to intend. That's the almost completed project. It's going to be handed over in the next 2 months, finally. A resort that we've done in Manali, again, as an example of file to factory, where each of these units was designed as a biomorphic pod that sits on the natural hill, replicating the mountains in front and sort of creating that whole biomorphic feel from within the site itself. So almost inspired from the anthill architecture. Each of these frames, pre-planned, pre-cut, produced in the factory, brought to the site. The site was extremely difficult to work with. It snows almost 3 months a year. And the construction time is only 6 months. So in that extreme condition, most of these frames, most of the structure was made here. And then this is the photograph of the completed project. Some of the views of the pods, the interior spaces, the precision at which a structure like this could be made in difficult conditions of Manali was only possible by using the automated techniques of CNC and file-to-factory production. This was the first residence we did in 2006, where we had used a similar kind of a system where the walls were not built using the traditional materials, but were made with using plywood slices, covered with ferrocement, and we got a very organic shape. So this is a very experimental project. In fact, every project of us is an experiment. It's a study for us to understand. So last 20 years of MOFA is more like a study in itself. We're an institution in itself to kind of learn and understand what the next level is going to be. Coming back to a standard factory-produced prefabricated architecture, which is something that we are pushing. A conceptual video for one of the houses that we are doing in Paschim Vihar. This was shown to the client in order for him to understand the whole construction process, where only the foundations were done on site, rest the entire structure comes like a Lego block, pieces coming from the factory assembled on site, including the precast walls. So the idea for us is to look into the future, and in order to kind of automate the process of design, construction, making it more democratic, making it more inclusive, we are not averse to using the machines. We love to work with the machines. Going to another house in Bangalore. The entire house is prefabricated. Even the complex forms, the complex roofs are all completely sort of worked out and done. The immersive house that you saw in Ishwarnagar or in Delhi is completely done in steel again. Coming to the point that we have designed houses and we're sort of marketing these houses now, which the entire unit is built into the factory, not as kit of parts, but as modules of almost 8 feet by 40 feet. And those modules can be assembled on site in a matter of 2 months to 3 months maximum. So much so that you could literally, in the future, order a house on Amazon, use the app, design it, put together, make the whole process so democratic that ultimately you do not need architects like us. That's complete house. Another project we're doing in Goa using shipping containers. We're recycling these 250 shipping containers, sort of prefabricating them off the site, about 20 kilometers off the site, as kit of parts where every window, every railing has been turned into an inventory, and that inventory is pre-worked out with various modules which come together on a site in Goa, reducing the carbon footprint and the pressure on the land by 90%. Lightweight foundations and everything above that is factory produced. So much so that tomorrow, if they decide to remove the project, the land is completely free and given back to its original shape the way it was. That's the view of the Goa Bazaar or Goa Hut, which is a crafts bazaar in Goa, designed completely using shipping containers and prefabricated. Now, this brings me to a point that apart from building the architecture or the physical look, or because a lot of times I've been questioned that it's a very form-based thing. Is parametric design only form-based? No, it's not. Parametricism obviously means parameters simulating certain kind of variables to get an intended result. So here we use data which is seamlessly available, and we call it, cloud computing is a word very commonly used. It's used in finance markets, it's used in various places to do predictions. Here we do predictions for the buildings, like a CFD simulation of wind for these structures in Goa, where we are harnessing the sea winds above 20 meters to bring down the microclimate of the land at the ground level in itself. So these are high-level CFD simulations where we fed in the actual wind data from the meteorological department and understood how the wind can be harnessed for our benefit. Acoustic simulations for the project in Goa, where the classrooms are all open, but sort of, yes. So these simulations helped us to control the sound spillage from one classroom to another classroom and design a system where just the use of these acoustic panels, how we could, without using any walls or partitions in between, contain the sound from one space to another space. For another project in Goa, the sunlight, the daylight analysis versus the solar heat gain analysis helped us understand what kind of facade, what kind of glass, what kind of nature of the outer skin for the building should be. Or people analysis. For a project in Kashmir, where a public building or an adaptive reuse project we needed to understand how the spaces are going to be used by, let's say, 5,000 people or 10,000 people coming in this public space every day. We simulated the movement of those people giving avatars in order to understand which are the most frequented stops or frequented points within this whole project that could be given, functions like cafeterias or the more public functions versus the more private functions. And these, or simply a water flow analysis. These water flow analysis have helped us, same site, which is a flood-affected site, in order to how to design the entire landscape by thereby understanding the real water flow of the rainfall. Or in fact, for the roof in Goa, it rains almost a meter per hour in Goa at times. So how does your building not get flooded? What is the roof slopes? What are the gutter sizes? We do very detailed simulations to understand all of that. And in the end, of course, there's poetry. We not only the machines. We have designed projects which also create immersive arts using the machine and the human mind. An installation done about 5 years ago, rather 4 years ago, called Room of Illusion, where it was multiple mirrors, and this is a performative space, and there's multiple mirrors reflect and give you a sense of infinity. The whole thing was simulated much before we actually went on ground. Office for Delhi Daredevils. Monsoon Salon. So there's always art, and there's always space making, people usage, and it's always a delight to see how these spaces are getting used. It's the interaction between the humans and the machines that sort of interest me at a personal level. And MOFA, over the years, has just sort of grown to understand and make this more into work in progress rather than, so we don't look at a project all the time saying that, okay, it's a completed project, let's take a photograph, let's shoot it, let's do a sort of a, this whole bang shebang about a completed project. A project for us is never completed. It should never be. It's always a work in progress. And every project, more than 160 projects designed in the firm in the last 20 years, each one is a learning from one to another. And I think we've just started. Thank you.